21st May GFG question, kth smallest number in multiplication table. So first of all, what is a multiplication table? It is a m cross n matrix where the each value, this matrix is basically one base index, and each value depends on the multiplication of its indices. For example, this 6 depends on the row index, that is 2, and the column index, that is 3. So 3 into 2, that is 6. Like if you consider this 15, the row index is 3 and column index is 5, so its value is calculated based on that. Now why is it called multiplication table then? If you observe carefully this, if you observe this column, it is basically multiplication. It's basically the table of 3, 6, 9, 12, right? If you look at any column or any row, let's say this row, it is table of 4 basically. That is why it is called multiplication table. So what they are asking is that you have to return the kth smallest number. Like suppose here in this example, the k, m and n are 7 and the k is 16. So if you store all these 49, all these 49 elements in a 1D array, then you sort them, then you have to find this 16th element, that is the one that is present on index 15. So if you sort this, the first 16 elements are these, and so you have to return the 7 as your answer. The constraint, if you look at the constraint, both m into n lies from 1 to 10 raised to 4. Now the constraint are very helpful in order to give your solution, your approach, a direction. If you analyze the constraint, you can get a hint of what should be the time complexity of your approach. Like if it were given 10 raised to 3, you can think of something n square, right? Because that might get accepted. But here it is 10 raised to 4, then you cannot think of n square because it will get TLE. If it was 10 raised to 5 or maybe 10 raised to 6, you only have to think of linear approach. But we are given 10 raised to 4, that is between the linear and the n square complexity. So you have to think of something n log n kind of stuff where you combine both binary search as well as the linear approach. Another hint that you get in the question is that it is a kind of question where you have to find an answer from a given range. Basically, we are given a range. What is the range? 1 and 49. Our answer cannot lie outside this range, right? It has to be in between 1 and 49. And whenever this kind of range of answer is given and you see the complexities like this, you have to think in the direction of binary search. And whenever this kind of range is given, you have to apply binary search basically from the starting, the least possible answer, that is 1, and the highest possible answer, that is 49. Because m into n, there cannot be any element greater than 49 in our matrix, right? So this is the range and you have to apply binary search here. Okay, now you got the binary search. Now we are left with linear approach. What do we do linearly now? So suppose we found the mid value here, 25, right? What do we do with this 25? So approach is to count the number of elements that are less than mid in our multiplication table. Now we have to find this linearly. We cannot traverse, or we cannot store the entire table, and we cannot traverse the entire table to determine the count of elements that are less than mid. So how do we solve this? So basically, for this we have to consider the characteristic, or you can say property of this multiplication table. So for example, how do you determine how many elements are less than mid in this entire column just by looking at the index of it? Can you determine it? For example, suppose in our first case, the mid is 25. So how can you determine that, okay, how many number of elements would be less than 25 in this first column? You can determine based on this value 1 actually. All you have to do is to divide the 25 by 1. So what you get? You get 25. Now, so basically, there can be 25 less than elements, basically less than or equal to elements than 25 in the table of 1. But here we are given only till 7, the value of n, or you can say m or n, you can say whatever you want, but here it is only up to 7 at max, right? So we have to take the minimum of this 25, that is the all possible number of less elements than 25 in the table of 1, comma the value of, let's say, m, right, or n, whatever you take, whatever side you consider as m and n, but you have to take this, right? If you have taken, if you are traversing, if you are traversing here, you have to take this value as your m, and if you are traversing here in this range, you have to take this value as your m. Okay, so like if you look at the 2, you will get it better. So if you look at 2, how many number of elements that can be less than 25 in the table of 2? It can be 25 by 2, that is 12. But here the in our table we only have up to 7 elements, so only 7 elements are here that are less than 2. So you just addition the first 7 and the second 7, so we got 14. And if you look at now the third column, in the third column you divide 25 by 3, so what do you get? You get 8, right? So at max 8 values can be less than 25 in this table of 3, but here also we are exceeding our limit of 7, so we add 21. Our updated answer is 21. Similarly, if you go forward, how many elements can be less than 25 in the table of 4? So that would be 6, because if you go above 6 you get 28. And how did you determine 6? It is basically 25 divided by 4, that is 6, right? You floor down the value, you do not consider the floating points and all, right? So the answer is 6. Now 6 is already less than 7, so in this case we have to consider 6. We have to take a minimum of all possible numbers that are less than the mid value in the table of a particular index, comma the maximum value of this limit m. All right, so that is how we determine the count of elements. And if this count is greater than equal to, suppose this count is, let's say, so k is 16, right? And suppose I'm just taking a hypothetical situation, that is not related to this example. Suppose we got the count as 18, right? Now this is greater than equal to 16, yes, then this can be our possible answer. How can it be a possible answer? Because it can have also like 16th position, 17th position, 18th position, all three might have same element. Then this can be our answer, right? So we will store this as our answer, possible answer, and we will move left, because there is no, it doesn't make any sense to move right, right? Our element resides in the left part. And suppose the count is, let's say, 12. So our answer is definitely greater than this value of mid. That is why we will move the right, basically binary search, two conditions. And here I've written the dry run of all these things. Like if you consider 25, the number of elements that are less than 25 in this matrix are 39. So the count is greater. This can be our possible answer. So we are storing 25 as our answer, candidate for answer, and we move left, right? Similarly, we are just doing these iterations. In the next iteration, right, this is the updated and we found the new mid, and this is the count. Then it's again greater than equals to. So we update our answer candidate. If it is not less, we move to the right part of the array, right? And similarly, at last we will get our possible candidate as answer 7, and we are going to return this. This is the simple code. This is the code to count the number of elements that are less than, count the number of elements that are less than mid. And this is the simple binary search. All right, you can get this code from the GitHub in the description, right? Thank you.